Good evening, one and all. Welcome to the data science program. In the previous session, we were looking at the boosting algorithm. We have seen the ADABOOST and the gradient boosting algorithms. To continue our discussion, we will do the coding of the cat boost and the XG boost algorithms in today's session. So, to have a quick look about what all the various topics that we had discussed under the theory sections of the cat boost and the XG boost, we will quickly have a recap. So, the XG boost was originally produced by the University of Washington. So, that was just their intention was to maintain the open source contributions towards the research field. So basically, this XT boost is available in Python, R, Java, and C, C++ as well. So this XT boost basically introduces the gradients of different cuts to select the next cut. Okay. In addition to that, it uses the Hessian, which is nothing but the second derivative, to identify the ranking of each of the cut that it is going to perform in terms of the data. All right. This next derivative, that's the after calculating the first derivative, if you want to go for the second derivative, there is a computational cost. Okay. But definitely, if it is useful in some sense, definitely that extra burden that's going to be present in terms of the computational cost, right? That could be useful, right? So the same thing is happening with the XG boost. And the one more algorithm that we are going to see today will be the cat boost. Okay. If you remember, we had discussed about the cat boost theory session where we had discussed that it was originally developed and maintained by the Russian search engine called Yandex. Again, it is supported and it is available. It is made available by various research groups for Python, R, C++, Java, Rust, etc. So it basically tries to optimize the decision trees for categorical variable. That's why the name is cat boost. And the variables whose different values may have no relation with each other. For example, if you are considering apples and oranges, there is no common thing between them, right? So cat boost tries to optimize the decision trees for this purpose. Then at the end, as a extra topic, right, we will also look at what is called as light GBM. It's the boosting technique supported and developed by the Microsoft. So this is again supported by Python, R, and C. So this light GBM has a very unique feature that it can construct the trees using gradient based and single-sided sampling, right? So that the whole concept is called as a gross. Okay, so that's the additional topic that we are going to discuss so at the end of the session today. All right, so let me bring in the data set for today's session. All right, what I do as usual, I'll put the data set on the chat box. All right, everyone kindly look at your chat box and I'll be adding it in 1 minute. 1 minute. All right, please give me 1 minute of time. So I'll also show you the data set that I'm going to add. Okay, let me connect this to the runtime first. And meanwhile, I'll bring in the data set So as we upload, it's going to give a warning saying that once you stop this runtime, your data set may not be available. Okay, so that's the standard warning given by the Google Colab. So it's actually uploading. I also have added the file to the chat box. Everyone, please download that. And also, I request someone who received this data set first, please put this onto your common WhatsApp group so that everybody can download from there. Those who don't receive through the chat, right? If there is some difficulty in receiving through the chat, I kindly request someone to put it on the common WhatsApp group as well. So you can see that the data set that we have today is loan stats3a.csv. If you want to look at the details of this particular data set, right, there is what is called as a lending club. So this is a data set from a lending club, which is actually a very leading platform that lends money to the people in need at a particular interest rate. That interest rate is based on the credit history and some other factors. So the data set is from there. It's a lending company data set. So we will analyze the data. We will try to pre-process. First, we'll look at the data for sure. But I suggest you, before we start coding, I want you to download it to your. Anyway, you already have it on your computers, right? Try to open that and try to look at that before we discuss. Okay, I'll be discussing about the data set maybe 1 or 2 minutes, so that I'm giving time for everyone to download this data and keep it ready. So if you are running it on a Jupyter notebook, it's better you keep that particular downloaded file on the same folder where you run your Jupyter notebook. Okay, mostly it is in the my document of your computer, right? But even if you are running it from your desktop, I suggest you to keep the file on the same page. Okay, so our intention initially today is to analyze this data. That's pre-processing, and we need to build a model that can identify the potential defaulter based on the history and the number of transactions and whatever data that actually is provided by this particular data set. So if you look carefully, this particular data set has 42,538 rows and 144 columns. And what are those 144 columns? We have to look at that, and we need to process it. So that's our fundamental goal for the day. All right. Now, so what we do, we'll start with the importing of the required packages. So there is a CatBoost package that is available. It's not a pre-installed tool, or it's neither available in any of the default format of Python, or again, the same thing holds good with the installation that we have on the Google Colab side as well. Right? So it is necessary that we will install that. We'll start from installing that. All right. So this is we can do the pip install. So if you don't want to see the display, you can write -QQ during the installation. Normally it prints out maybe one or two pages of the status commands, right? So you don't want to see that, means you can write a -QQ. Just go for install catboost. All right, so this is the first command that we are going to run today. So only it will show that, okay, the installation is complete and there is one small bar of display that's going to happen, right? So you can see that it's installing. Now the installation is over. Now let's import the other libraries as required, right? So import numpy So we will bring in the Seaborn for plotting. Also, we need matplotlib to plot, to have some visualizations. All right, then let me import the various tools required from the sklearn. From sklearn dot the model selection, we need to import a particular function that's called as train test split. All right, then again from sklearn dot pre-processing will import what is called as the label encoder. All right, then in order to measure the accuracy and to get a classification report, we have to import them from sklearn.metrics. Accuracy score we are bringing from there, as well as the classification report. Then we need the decision tree classifier. It's actually present inside the sklearn as a tree. All right, so from sklearn.tree import decision tree classifier. All right, then we need the boosting algorithms to be brought into the memory. So from the cat boost import cat boost classifier. Also, I need what is called as a pool. I will bring in the metrics, and let me also bring in C. Okay, then from XGBoost, so from the XGBoost, let us try to import XGB classifier. Okay, then light GBM, mistake. Well, import the LGBM LGBM classifier. All right, then warnings, then we'll filter the warnings, saying whichever warnings are there, I want to ignore. Okay, so that's about importing and setting the base ready for us for uh, doing this many project. All right, so let me go for the reading of the data. So that loan status data which is present in our memory will bring it into the computer. All right, so we'll use a pandas pd dot read csv. So let us look at the name carefully. It's a loan stats 3a.csv. All right, so we need to write it exactly as it is given over here. So we'll write that here. Loan stats 3a.csv. All right, so let's read that. So that data is read and it's present inside the variable data. So let's look at the shape. All right, then we'll look at the various okay, let's look at the data. Say for top 5 or 10 rows of data we can check that. All right, so that is data dot head. So you can see that ID, member ID, loan amount, funded amount, right? Many things are there. Like that, how many? Oh, we can see a lot of not numbers over there. Okay, this is going to be really interesting how to see how to handle this kind of data set. Because practically we will be observing something very similar, right? Whenever you handle whenever you try to get a data set which is really practical data, and whenever you want to process it, right, you will face this kind of. That's why I said this is pretty much interesting to see how to look at this. So I think we already have seen the shape, right? The shape is 42,538 rows and 144 columns. Okay, let me look at the info. Okay, so many entries, 144 entries, starting from the name ID to the last column, that is a settlement term. We have 115 columns of float type, and there are 29 objects. So total size of 46.7 MB. Right. So let me look at the null items first, because I saw a lot of null items in the data. Is null. I'll ask the question is null and take me a sum of that. So column wise, I should be able to see something over here. So you can see that so there are 42,378. Oh, okay, almost everything. Like I don't remember how many. What was the shape we had? Let me check that once again. Data dot looks like almost everything in some of the columns, right? All the entries are null, I guess. You see here, the total size is 42,538. So 42,538 completely null. Only one of the item has a ID there. 42,378. Oh, so near there. So let's check. Let's try to find out how many missing values are there in total, right? As a percentage, because I'm very sure that it looks like more than 50% for me, but I just want to make sure. So again, this is actually a test for your data analysis skills, right? The exploratory data analysis which you need to do in any of the data science projects, right? You may have to do something like this before you go and delete the null items or do something with the null items. So let's try to find out that. All right, so I'll try to write what is called as percent, or it's a fact. It's a fraction. Better to write in that way. So I'll write data dot is null dot sum. It gives me the one which you can see in the cell number 7. I want sum of them. So dot sum. I'll do again sum. That actually gives you how many total entries are you have, how many of them are null you have, sum of them. So divided by. So go to the data shape 0, right? That's actually the number of rows into data dot shape of 1. So if you see the data shape 0 means this number, data shape 1 means this number, right? So I totally have that many numbers, but I think I need to put a braces over here, otherwise this will be a different way. All right, so that's what is a fact. Let me check. 63, right? Okay, let me try to write let me print something so that this is useful. All right, so total missing values in this data set equal to, let me bring in a format specifier. So I'll just write dot to float. I want a floating value. All right, and I add a percentage, then dot format. That the fraction which we have calculated, I need to multiply that with 100, correct? So because I need the answer in this format, let's run this. So you see 63.14%. So what's the conclusion? So by doing this particular type of data analysis, we could understand that in this data set, 63% of the values are missing, or they are null values maybe, right? So let's also try to do another type of visualization. Normally you will be able to do the same thing whenever, I think we have done the same visualization. Which visualization we already have used for visualization of the null values? Anybody? Yeah, it's a heat map, correct? So let's bring in the heat map to visualize this, just to see that, okay, I should be able to see the 63% visualization. So already the PLT is there in the memory. I can simply use it. Let me call a bigger. Big size is a keyword to specify the size that you want. All right, so let me say 14. No, that may be too big. So 12, 12. Okay, using a Seaborn, I can call heat map data dot is null, whatever the null I have, only that I'll try to bring in into this. So let me put a title. Null values in the data set. I can specify the font dict as well, right? You just have to give a dictionary over here. Font size, specify the font size, whatever you want. Maybe I'll say 25, or it may be larger. Let me put only say 50. Let's see if it is too small. I'll change this at a later stage. Okay, then plt dot. Let me bring in the legend and data dot is null. That itself, I want to use it as a legend. Show that. So it's a huge data set, taking some time to bring in the heat map. So you can see that, right? So I can see that whatever is pretty much darker, right? So that is having a lesser value. But if you come to the top, right, this is brightest colors, they are the null values, highest null values. So I can see that, yes, a lot of null values do exist in this data. So what I try to do here, let us try to select the columns having null values less than say 50%, or maybe lesser than that, because 50% may not be suitable. Let's go for a 40%. Okay, so I try to create a data frame and I'll try to create the null values as well. So how many number of columns have what percentage of null values I want to find out. So if you remember, there are 144 columns. I want to create a data frame that actually holds the count of how many how many columns have 10% or less number of null values, 10 to 20%, 20 to 30, 30 to 40, like that. I want to create a new data frame because it's not at all. I cannot remove the columns containing them directly, all right? Because in such case, since my data set has more than 63% of null, removing them directly may affect your data set very badly. You may lose a lot of information. I don't want to go with that, right? Yeah, so those columns which are having more than 90% of null values, you can remove them, no problem, right? Or more big, but when you remove them, you may lose those other rows or columns which have some information present in your data set, right? So don't want to do. Okay, so let's try to create a data frame. I'll call it as temp df, temp data frame. We'll create a pd dot data frame. Okay, and in this temp data frame, I want to bring in, say, a particular column. Let's give a name, percentage of null values. Okay, it's a name of the column. So that name I want to give like this. So the first one is 10% or less, the first name. Then second one is 10% to 20%. Between 10 and 20 is what I want to calculate. So I can write, I can make it as 11 because 10 or this is included over there. So 11% to 20%, maybe that makes more sense. Then 21% to 30% is the next one. Then this is 31% to say 40%. Then we have 41% to 50, right? Like that, we create all the possible, right? So this is what is my intention. 41 to 50, then definitely 51 to 60%, then 61% to 70%, then 71 to 80, 81% to say 90, and the last one will be, let's write like this, so that is more than 91. And modify this less than 10%. Okay, so this is what I create. So we have a temp def now. So you will understand now. If I inspect the temp df, so you can see that, right? So row wise, I created one column only. So I'm going to add the next column to that. Okay, so how many number of columns have less than 10% will come here, 11 to 20 will come here, and so on. Okay, so that's my objective now. So I'll calculate the first part, that is 10%, 11 to 20, 21 to 30, and so on, right? So let me calculate them. Less than 10, right, is equal to, I just need the number, so I can use the length of data dot columns. In the columns, you need to find out something, right? That I need to check. What I need to check? I need to check the data dot is null dot sum. Data dot is null dot sum divided by the length of the data, correct? Because this percentage, this ratio should be less than 10%, correct? So divided by length of data. So do I need another bracket over here? Let me check. Length of data. Okay, so length, where I'm closing this length. All right, where I'm closing this, I think I'm fine, but let me just less than, I want to include even 10%, right? So less than or equal to, this ratio should be 0.1. Let me try to calculate that once. Okay, I think I have done some, none is happening over there. Okay, let me try to check that once again. Length of data columns. Let me use a bracket here. Data dot is null dot, this closes here. I need one more. Let me say open here, and okay, I got it. Sorry. Slice should be happening after this, correct? So close this and I close this. Now let's check invalid syntax. What happened? Should not close this, right? Okay. Let me try to print out. It says 52. So there are 52 columns which have less than 10% of null values out of the total length. Okay. Like this, I need to find out all possible values, and then I'll add another column, right, to this data frame. So that's going to give me a very clear idea about what approach I should use for my pre-processing. Okay, so let me try to bring that. So ten to it's 11 to 20 should be equal to. So let's apply the same logic over here. Okay, that is equal to, once again, it's a length data dot columns of data is null dot sum divided by data, is it data? No, length of the data. Length of data should be, I have to write two conditions now, greater than something and less than something, correct? So first let me write greater than. Data is greater than 0.1, then I write a AND condition, and so let me put one bracket here and one bracket over here, right? And let me copy the same thing. After this AND, I'll paste that. So now you see this should be lesser than or equal to 0.2. All right, let me check. Somewhere I have close extra bracket. Let me length of let me check again. I think I should have used one here. My mistake. Okay, let me just verify. Still there is an error. Okay. Always we need to be careful with the brackets, correct? So let me check this once again where I'm closing this. This is closing over here. Okay. So where is this getting through? This one? It's here. Where are you closing this? It's there. Then I don't need this one, right? Because 0.1 and data dot columns. Okay, let's try to solve this. Data dot columns greater than 2. Yeah, sure. I got it. So I need to close this, right? That was my mistake. And data dot columns of data, whatever I have opened here should be closed again over here, isn't it? Okay, it should be a separate one. I think that was my mistake. Sorry. So yes. Right, like that. We'll do 11 to 20, then 21 to 30. What I do, I'll copy everything, only I'll make the modifications. So this is more than 0.2, less than 0.3, and 21 to 30. So it says 0 over there. Okay. (31 to 40). So let me give the names with the less characters. Let me make it less than 10, right? So that's variable name. 11 to 20, 11 to 20, to 30. Okay, so like that. 31 to 40 should be equal to, paste it. So this is 31 to 40 greater than 0.3 and less than 0.4 and 31 to 40 is what I want to see here. So it says 1. (31 to 40 is over. Then 41 to 50. (41 to 50 is 0. 51 to 60 more than 0.5 but less than 0.6. It says it's also 0. Okay, no problem. 61 to 70. that is equal to 61 to 70 is done in that way. (71 to 80) will be calculated next. Very same way, more than 0.7 less than or equal to 0.8. So we'll be able to see 71 to 80 like this. Is 81 to 90 is also 0. Fine. Then we'll write the last one, that is more than 90 will be equal to. So I don't need this AND part. I just need something which is more than 0.9. So see, it says 90, there are 90 columns which have 9 more than. So okay, let me bring in the, what do you call, the DF itself, data frame format. Okay, the temp DF. I'll add a column saying number of columns in data set should be equal to less than 10, not 10, I think 11 to 20, what does that mean? 20, 21 to 30, 11 to 20 is over, then 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90, The last one will be more than 90. Okay, so this is what sorry, 11 to then let's inspect. Right, so we understood that. Now, so if I try to calculate up to 40%, right? So you have 52 plus 1, 53 columns should be there, right? In your data which you handle. Like again, this is at random. You can even consider, see, up to 70%, you just get one more column. So up to 50%, 60%, it's still the 52 plus 153. You can even consider only this 52 columns, that's fine. But I just want to show you, right, how do you write up to 40% if you want, what you can do, you see. Then definitely it's left to you, you can modify code. So what I do, I try to create a data frame, df1 is equal to data, right? From the data, take the data dot columns of, right, data dot is null dot sum divided by the length of this data. Okay, we will say that if this is lesser than or equal to 0.4, okay, take only those. This is what is the df1 dot shape. So how many columns we expect? 52 plus 1, 53. Correct? 52 because it's less than 10%. One more column will be there if it is less than 40%. So 52 plus 1, 53 is what I expect, number of columns. Let's see. So you see, so many rows, 53 columns. So by considering the columns with less number of null values, you can see that we are able to decrease the total number of columns from 144 to just 53. So we now have to deal with the null values present inside this 53 columns only. Other than that, so because you can see that 41 to 50 no columns, 51 to 60 also no, 61 to 71 column only, more than 80, 90 no columns, more than 91% you have 90 columns. Anyway, they are of no use to. Right? So this is one of the approach. What now let us try to check the columns that have right single value in that, right? Number of unique entries equal to 1 is what I am trying to find. In the sense, they are only constant. There should not be a null value or something different, because we are dealing with 53 columns. Again, this is huge. We'll try to find out. So let me try to write, in a sense, see what my goal here is. I want to check which are the columns that have a single type of entry present in that. Single type of entry in the sense, number of unique is 1. Okay, n unique is a command which I can use, is a function which I can use to check that. I want to find out those names of the columns which have the n unique equal to 1. So but anyway, it's I just have to use a for loop. So constant columns is what I try to create. It's a list. Then for the inside this, I'll check if df1 I, that's a column name, dot n unique equal to 1. Do something. What is that? Const columns dot append this column. Is it I? Sorry, my mistake. It should be call, right? Or that column you append. Try to run this. And sorry about that. It should be n unique, correct? N unique, yeah, sorry, it was a spelling mistake. So now I will check print of let me check what happens if I just inspect. Will it print one below the other? Const columns says null. Again, my mistake. Sorry. It's actually a function. Yeah, so I can see that these are the various columns which you have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can try to drop those particular columns which have these single value present in them, right? Because they're the constant columns. So if you have a single distinct value, you can simply neglect, right? We want to have the variations present in them, right? Otherwise, right, it may not be a good one. So let's try to visualize that. So df, so let's try to write the df1 dot, go to a particular column by the name, or df1 of, so it says the pymt plan. So you see it's all are same. It's completely the same thing everywhere, right? You can even change the and change it to any other. So out underscore prncp. Let's try to check this once. See, all are same. Unique values is equal to 1 means throughout the column you have the same value. It's not changing at all, right? It may not be null, but you don't have any other this thing. So this means you can drop all these columns. Okay, so let me try to show that. So let's check. So df1, just to confirm, my mistake, sorry, shape is not a function, you cannot call it, right? So 53, what I do now, in the df1, you can call what is called as drop. What do you want to drop? You just have to say that constant, constant columns. This one you need to drop. You need to drop all the columns. You just have to say drop columns. So by specifying axis, right? So axis equal to 1 means it's a column, right? Those names, check those names and find out those columns and delete those columns. And I have to update back to my df1 itself. I don't want to create a new data frame, right? How can you specify that? By saying in place equal to 2. Okay, I do this, then I'll check the df1 dot shape. What do you expect? There were 53 columns, out of which 9 columns I'm trying to remove, right? So when I do that, you expect 9 less than that. So 44, should it be 44? Let's check. Yeah, 42, 538, comma 44. Okay, now let's try to find out some more details about that. If at all, okay, let's try to do this. I want to find out the columns in the df1 which contain information in a format other than the numerical value, right? Anything other than numerical is what I want to find out. So let me try to find another set of let me give a name as columns that is equal to, from the df1 columns, find out the df1 dot dtype. Is it d type? D type, yes. Equal to, it should be object. Let me try to find this out first. How many are there? Let me check them first. So how do I check? You can simply check that by df1 of all. In a sense, only those indices will be addressed now. Head, it says what you have. Okay, so you can see that something like this. So let's try to find out. Is there any data? Okay, let me try to, I don't want all of them, I just want say 2 or 3 of them. Okay, this is better. Let me check what else we have. Issue, okay, see there is a date time object, December 11. See, Jan 85, April 99, Jan, May, something like that. So you need that date, right? So you cannot simply neglect them, right? So what I can try to do here is that I can try to convert them properly into the date time, right? I need something like that. Okay, so let me do that first. So as I told, first I'll handle the objects. Those actually contain the date or the time. So we'll use it, right? There is a function inside in the pandas which can convert string to date time objects. Okay, you can convert into that. So let's try to first identify what are the uh, date columns. So let me check that from the issue date, right? So that's the first one. Issue D. Then earliest. CR line. Then you have the loan payment. Okay. Loan, is it? Sorry, no, it's not completely written, right? Earliest CR line, then last, sorry, it's not loan. It's a last underscore PYNNT underscore D. And the last credit, that's one. I think we have 4 columns which contain the date, correct? So last, credit, full D. Okay, so that's how I create this. Then for I in date calls, I'll go to the data frame of I. Those values I'll try to change. Okay, equal to PD dot. There's a function called to date time. You can convert into the date time object. Okay, of I just have to specify what I want to change. That is once again df1 of I, right? That itself you want to change to as type, right? It's actually st. All right, comma. You need to specify. Okay, I'll go to the new line so that this becomes visible. It will not get extended. Okay, so format is equal to. I just have to say that the format specifier like percentage b dash percentage y. Then I need to specify whether I need year first or not, right? So I don't want the year first. Okay, so year first. All right, let me run this. Sorry, there's a typo error. It's as type, not. df1. Okay, so it says now it's correct. So let's try to check that once again. df1 of date calls dot head. Right, so you can see that those are converted into this form. Okay, then let's do something like, so from this earliest CR line, anyway, this date may not make any sense to us. So what we do, we'll try to convert only year. Okay, so that is df1 earliest CR line should be equal to pd dot date time index of df1 earliest CR line dot year. Okay, I'll check this once again. Okay, so it actually uses only the years over there. Then, so we can try to extract, get more features out of here, right? By converting the issue D, whatever issue D we have, I'll split that into years and months, and last payment D also I'll split it into what you call as years and month. Also the last credit pull, right, I'll split that into year and month. So let me try to add a few more things, like you are trying to get more features over there. All right, so let's try to do this now. df1 of issue D converted into, I think that is what is already called as issue D, right? There is a issue D, right? We can see that on above. I'll split that into year. So how to do that? So that can be done again by using the same function pd dot date time index of df1 of issue D dot year. Okay, df1 of the next one is last PYMNT underscore D underscore year equal to PD dot date time index of df1 of the last underscore PYMNT underscore D dot year df1 of last credit full D year equal to PD dot date time index of df1 of what is that full D dot year. So converting everything into year happens here. Again, the same thing I want to put it into the month, right? So I'll copy that same thing. See, I'll modify this into just the last part. Year, month. I'll change only them to month. Okay. Month. This also I'll try to change it to month. So the change happens over here. Dot month everywhere. So this data is actually containing the years till 2019, right? So every year we can actually subtract from 2019 to convert these numbers into the smaller number. All right, so let's do that now. df1 dot earliest CR line, okay, df dot this is equal to 2019 minus df1 dot earliest CR line. That's one thing. df1 dot issue D year. Just now we have okay, that is equal to once again you can do the same thing, 2019 minus df1 dot issue D year, right? Then df1 dot last payment also has year, right? Equal to 2019 minus df1 dot last credit full D year. One more, df1 dot last payment DEO equal to 2019 minus DF1 dot last payment DEO. Okay, so now we have the years and months available. So those original ones, these three, issue D, last payment, and last credit pull D, these three things we can actually eliminate, right? So let's do that. DF1 dot drop. You have to mention list over there. Okay, so the list containing will it suggest? Let me check. No, right? Let me enter ISHUE underscore D. This is the first one, comma. I want to remove the last PYMNT underscore D, second one, and the third one is last credit full D. I just want to remove this and specify x is equal to 1. Want to remove the complete column. In place equal to true. Okay, once I do that, I will check the current shape df1 dot shape. I think 44 plus 6 minus 3, 47. Okay, let's expect. Oh, my mistake again. No braces for this because it's not a function. All right, so we are halfway through this data pre-processing. Now data has been converted into some shape, but it's not the perfect one. All right, so what we do, we'll take a quick break, and when we come back, we'll be continuing from this point. We'll be handling the missing values that is present inside this updated data frame first, right? Then we'll look at the handling of null values that are present over there. I think if we are done with that, then we are good to go with the modeling. Data modeling can come into picture immediately after that, so that we can do the boosting algorithms on that. All right, we'll continue from where we left. So we have modified our data. The data frame has been converted into a new type of data set, data frame. So we have removed the original columns containing the date time. We converted them into the years and months, like you can see in the cells. All right, now we'll try to explore the null values once again, right? So in this remaining data set, right, whatever data frame we have left out with right now, so we'll check the null values. All right, so plt dot figure fig size equal to, say, 14, 14, then SMS dot heat map df1 dot is null, then plt dot show. So we can see that, right? We have very less this bright color, right? And almost everything is dark color. Very less number of the null values. Okay, so now let's try to handle the null values in this data set. Let me try to create a variable. A is equal to df1 dot is null dot sum. I want to divide that with the df1 dot shape, in the sense the number of rows, right? I'll try to multiply that with 100 so that right, we get something like this. Now let me try to have this, the b, I'll try to convert it. B is equal to a of a greater than 0 0, and then say b is equal to pd dot data frame, convert this b into columns as percentage of null values, then b dot sort, there is a sort values function. Using this, what is called as a sort value function, we'll be able to sort it. Okay, so I just have to say by equal to which particular column you want to sort, you just have to specify. So that's same as the one which we created now. Percentage of null values, ascending equal to false. In a sense, it will be in the descending mode. So I'll be see, I can see like this. All right, let me check the. All right. DLQ in 2 years is what is we need to guess that. So what I try to do here is I try to drop out those rows which have null values in these columns. Okay, so that's why I'll try to write. I'm writing this command. So df1 is equal to df1 of df1 of uh, del. That's the name. Let me try to find out once again. Yeah, DELINQ. DELINQ underscore 2 years. Okay, DELINQ underscore 2 dot not null. So now the df1 changes its shape. Okay, so we are reducing the rows now, not columns. Once again, we'll check the not null. So the same thing which I have written earlier, right? I think I can write the same this thing. So I'll just, okay, whatever I have written, I'll write once again very quickly. So that is A is equal to df1 dot is null dot sum. So this I divide this with the df1 dot shape 0, and I'll multiply this with 100. So that is A. Then B is equal to, I don't want 0, so A of A, sorry, A of A, this is greater than 0, just to make it a float. Okay, then B is equal to PD dot data frame of B, comma, columns equal to percentage null values. Oh, sorry, it's a string, so I just have to write it. Single quotes are double quotes. That's what is required here. Then B dot dot. I have to specify by equal to, specify which one you want. That's percentage null values, VALU values. Okay. Ascending equal to quotes. My mistake. It's not sort, right? It's a sort values. Now we see it, it's reduced, right? Earlier we had larger values, now so many values were there. Right now we have lesser meters. So there are missing values now, right? Percentage of null values or missing values, whatever you have here. Right? For each one of them, we'll try to replace it with the median value. So I can use a fill NA technique. df1 will suggest, let's see. Okay, so I'll just write them by myself. Last underscore YMNG underscore D underscore here. I'll apply fill NA, right? I just have to take the same thing with median. All right, so that is df1 of last D year dot go to the median value, and you will specify that in place equal to 2 as the first one. Then df1 payment is over, payment month dot fill NA df1 that's a month itself dot median comma in place equal to 2. df1 last, let's go to the credit here dot fill NA df1 of last credit year dot median in place equal to 2. Then I'll do the same thing for df1 of last credit for the month fill NA df1 of last last credit for the month dot median in place equal to 2. Okay, then I'll do with the same thing with the tax lines as well, because I can see that null values in these columns are less than 0.5 size. Right? You can see here, this is what we are trying to do, right? So it's less than, missing values are less than 0.5. So I can try to do something like this. So df1 of tax lines dot fill NA df1 of tax lines dot median comma, in place equal to true. All right, let's try to run this. Okay, and there is one thing called as revolve actions over revolve utilities. If you check the revolve utilities, so let me try to do that. df1 it's a percentage value. So that value I'll try to fill it df1 dot revolve util dot fill NA. It's actually a percentage value, so I'll simply try to put it with I'll update it with 50%. Okay. In place equal to true. Again, so I replace this now. After that, I do that df1 dot revolve this util equal to df1 dot revolve util dot apply. Will apply what is called as a lambda function of x defined as x everything until the last one. So what I'm trying to do here is just extracting the numerical value, because you see everything is 83.70%, 9.40%. So except that percent, I'm trying to extract everything. So that's why this becomes this is the extraction part. Then I'll convert that string into float. df1 dot this should be equal to df1 dot util dot as type. Go to the as type, specify that as, is it sorry, float. So everything will get converted into the float by this. So there is one more thing that is called as, let me try to look at the unique values present over there in this. All right, public bank records. So df1 dot pub underscore public record is dot value counts. So this looks like an imbalanced data, correct? So in this case, other than the NA values, we have 0, 1, and 2 like this. Okay, so we'll try to fill it out with the NA, fill the NA values with the, let's say, maybe the median. Once again, df1 of dot fill NA df1 of dot median in place equal to true. Then let's try to find out the unique values present over the employee length. You can see that the employee length is again one more thing that also we need to handle. Okay. df1 emp underscore length dot value counts. Okay, so all right, let's do a random thing here, because again you can put the randomness, you can bring the randomness into picture over here. So I'm trying to put random thing. Let's replace df1 of this emp length dot fill NA I'll put 5000. I want to show you what are the various things you can do. You can even put the randomness over there, right? Little bit of randomness will not change anything. Okay, now we have that 1 year, right? Less than 1 year, right? Etc. So that less than 1 year and 10 plus years, right? I don't want them to be present in that way. I'll try to make a modification here. So that is df1 dot m length dot, I can use a replace command, right? I just have to specify what is present over there and what you want to replace it with. So there is what is called as 10 plus years. This is the one which I want to replace with just 9 years. Then okay, simply I'll put it as 10 years. This is the first thing, comma. Then I have another one which says less than 1 year, correct? Okay, you can see that that is there. I want to replace this with 1 year already. I think I have, right? Maybe 0 years. In place equal to true. I want to do this. Next, df1, right? I just try to extract the numerical length, right? So you can see that 0, 1, 2 up to 10. I can try to extract that. So df1 dot emp underscore length should be equal to df1 dot emp length dot apply. Again apply a lambda function x where you try to get x of, start from beginning, go till 2, 0 and 1. Okay, so it actually returns a string containing only the numerical value. I need to convert that into float once again. So df1 dot m length is equal to df1 dot m length as type. What's the type we require is float. Okay, so that actually handles the m length column. Now let's let's once again try to look at the null values again. I think I already have written a code for that. Let me try to bring that, right? Already have it, so I'll just so title, I think I don't want that, right? So DESC also I don't want, M for title, etc. Okay, I can just drop them. df1 dot drop, just specify those names. One is ESC, one is EMP underscore title, and the next one is simply title. So let's do that. Then you need to specify access equal to 1 to say that drop those columns. In place equal to 2. All right, let's do that. df1 dot is null dot sum. Hope we don't have any null values now. Yeah. Okay, so you have so many columns and you don't have any null values. That's good. Okay. Now I need to look at the categorical. Right? Let's try to look at df1 dot head, say 2 numbers. What else we have? Okay, there are some categorical these things left over, correct? Other than that, we have numericals. Okay, so let's deal with that now. Let's look at the term dot unique 36 months and this. Okay, then unique values in the interest rate. Okay, because that's also pretty important for us. So df1 int underscore, yeah, here also I want to find uni unique. Oh, try to get say some 10 values, maybe that will give us some idea. Okay, term and interest rate are what we need to find out. We need to remove that percentage, and from the 36 months, 60 months, I don't want the months to be present only. Okay, so df1 dot term is equal to df1 dot term dot apply. I go for a lambda function of x, where for every x I need, it's a term, right? So 36 space, 36 space. So till space I need that, right? So I'll try to write x of everything until the third one. Okay, this is what happens now. Then df1 dot term is equal to df1 dot term as a type. Is it sorry, my mistake. We have written it's term dot as type float. Okay, then once again df1 dot int rate should be equal to df1 dot int rate dot apply. I just have to go for a lambda function x, where I'll try to, now you see interest rate is like 10.65. Okay, so I'll apply until 2. Okay, only the complete number I want to get that. Okay, 10.1234. Okay, so I'll try to extract that, and then df1 dot rate is equal to df1 dot int rate as type float. Then df1 dot head, let's see that. Now term and interest rate have been modified. So let's check what else we have. So there is a zip code, correct? I don't want that. Dot drop zip code, keep access equal to 1. I create a df2, and let's look at everything other than this, like okay, we can see that there are many categorical variables left over, right? So only let's deal with the categorical these things, like purpose, verification, status, and address state, debt settlement flag, purpose, I think we can even deal with the verification status and home ownership, right? So those things we'll try to modify. Okay, so let me try to write that. So in df2 is equal to pd dot. So one hot encoding, right? We already have used it under the other machine learning topics, right? If you have doubt, any doubt about that, you can go back and check it, right? One hot encoding in pandas can be done using the get underscore get dummies. Okay, so df2 comma, I will tell columns, which are the columns that you want to apply. Okay, so I will apply that for home, this is one column. Then I want to apply this for verification status. Then I want to apply the same thing. Verification status, then the purpose, address, state, then drop first equal to 2. So we'll do the one hot encoding over here, and then I'll check df2 dot head 2. So there is one more thing that is remaining, which is the grade. Okay, let's create a label encoder for this. So LE is equal to label encoder, then LE dot fit df2 dot grade, and LE, okay, I need to print LE, that is label encoder dot classes. Oh, no, it's a single underscore. Yeah, so there are so many classes. So we'll update the grade column in this now. So we just have created the classes over here. So df2 dot grade is equal to le dot transform df2 dot grade. Again, there is a subgrade form you can see here, right? So for that also, let's apply the same logic. le2 is equal to label encoder le2 dot fit df2 dot that is what is called as a subgrade. le2 dot classes. Okay, so these are the various classes, right? You need to upgrade that. So df2 dot subgrade is equal to apply le2 dot transform df2 dot subgrade and df2 dot head. So we have one more this thing that is called as the loan status. df2 of loan status dot unique does not meet the policy. So you can see that there are these 4 different types. So let us try to separate it out, separate the data according to our data frame now. All right. So x should be equal to, from the df2 drop only this loan status, except loan status, whatever is there, it's my prediction features. All right, axis equal to, this is x, and I need y is equal to df2 loan status. So x and y we have. So I will verify y dot value counts. You can see. So fully paid, these many numbers, charged off 5670, does not meet the credit policy, right? And does not meet the credit policy, and with the status which is called as charged off, you have these many numbers. All right. So let us try to fit various what you call. Let's use the label encoder to convert these, right, categories into some numbers. All right. So le3 is equal to, once again, label encoder le3 dot fit the y, and y transformed is equal to le3 dot transform y, and y transform. All right, so let's look at x dot add once. Right, 106 columns. All right, I think we are good to go with the model building. So far whatever we have done is a exploratory data analysis and the pre-processing part. So normally you see, though we know that how to model and how to write a model, coding of the model, Majority of the time is always spent in the EDA part. This is what I was highlighting whenever we were discussing about the EDA, right, earlier. Okay, so let's go with the X train, X test, Y train, Y test, that is equal to train test split of the X as it is, and instead of Y I'm supposed to use Y transformed, comma, test size is equal to, let's go with the 0.2, then clarify equal to Y transformed, random state equal to pick some number. Let's try to verify X train dot shape, Y shape, X test dot shape, Y test dot, just to verify we are on the right track. Okay, so yeah, looks fine. We'll start with the model. Okay, I'll call it as a my decision tree is equal to D decision tree classifier criterion equal to Guinea random state equal to 100. I'll specify various hyperparameters now. Max depth equal to say 3. If it doesn't work or if the performance is not good, I'll definitely change it later. Class weight, let me try to write it as balanced. Min samples leaf equal to 5. Okay, so that is the requirement, and then I'll directly train it. My dt dot fit x train, comma train. My dt predict is equal to my dt dot predict x test print accuracy score of y test, comma my dt predicted. So we can see that it comes closer to 94%. All right, now we'll go for a cat boost. Right, so CLF cat boost is equal to cat boost, spelling mistake or not? No, class boost, cat boost classifier. I just have to specify iterations equal to any number, maybe 10. Then learning rate should be equal to any number you can keep. Let's keep it small, 0.1 should work. If it does not work, change it at a later stage. Okay, then you have a complete freedom to choose various other parameters as well, like which loss function you want to use, etc. Many things you can do, but anyway, as of now, let me not use it. Okay, so CLF CB dot fit, what I try to do here is X train, Y train, verbose equal to 2. Okay, if you don't want to see, you can make it a false. Okay, then PB prediction is equal to CLF PB dot predict X test. Then I'll go for accuracy. All right, so print accuracy score of the Y test. I'll write first test, comma, this is 96.8. Also, let's try to go with the classification report, right? Classification report on the Y test with right. So we can see that approximately accuracy touching this. F1 score is between the precision recall, right? So that's the implementation part of this, what is called as the cat boost. And we can see that cat boost actually is much better than the simple decision trees. Right? Now I will show you the implementation part corresponding to XT boost. Is equal to XGB classifier. You can specify various parameters. I will just use learning rate equal to 0.1. Please use the help of XGBoost classifier to get to know about what are the other parameters you can specify. All right. So we'll fit X train, Y train, So next I'm going to predict XCB PRED will be that. Then print accuracy score corresponding to Y test with the XGB. So this is going to give you the prediction value. Okay, 98%. Then print classification report of the same thing, Y test with the XGB. So the same similar result we have obtained earlier, right? But this here you can see the accuracy is touching 0.99, right? So that actually completes our the boosting algorithms implementation. But as I mentioned earlier, I want you to look at one extra content here, which is a boosting algorithm that is implemented and originally designed by the Microsoft. Right? So it's called as Light GBM. So I'll quickly show you the implementation of that app. Right? So is equal to LGBM classifier learning rate is equal to 0.1. So we'll create this first, then CLF LGBM dot fit X train Y train verbal is equal to true. Okay. LGBM PRED. Okay, predict. I want to get the predicted result, so that is ELF LGBM dot predict X test, then print accuracy score of Y test with LGBM. So again 99 point something. Print the classification report of Y test with okay, so that is the implementation of LGB. All right, so with that we have come to the end of today's session. You are free to go ahead if there are any doubts or any questions you have. I want you to go back to the theory session we conducted before last week's class once, so that you can understand, you can recall the complete theory aspects and mathematical representation of these boosting algorithms once. All right, once you have done that, watch this video once again so that you understand the implementation part as well. Okay, in addition to that, you will get a lot of resources in the internet as well as the standard textbooks, which will give a very clear explanation of the whole concept as well as the implementation part. I also suggest you to repeat coding by taking various examples available in the internet or various challenges that are put up over internet, right? I also suggest you to take part in various Kaggle competitions, right, which actually are good resources to get trial and error and learn a lot by doing the coding. All right. I hope this session was useful to you. Okay, I appreciate your time and patience listening to the session as well as doing the coding along with me. So we'll meet in the next class. Until then, have a great time.